Course 2, Lesson 4. We are going to be on page 26 today. And today we're going to go over a couple of concepts. First of all, we're going to talk about a number line, and you see that right here. And then we're going to talk about sequences, and sequences are basically how we use numbers to jump a certain thing. For like instance, if we say 1, 3, 5, we know that that's odd, or 2, 4, 6, and we're going to give a couple of examples like that. Okay, so a couple things to work on today. All right, so let's look at first of all a number line. This is a number line. Okay, and we're going to define a couple things. Okay, we notice 0 is right here, and we call that an origin. An origin just means that that's where we start. Everything starts at origin. So if we go this way, we would use this symbol, that it is greater than. So, or a symbol for greater than, excuse me, is this way, greater than. And you notice the mouth is open here. So when we get that symbol of greater than and less than, okay, it looks like an emoji, right? Okay, we won't do an emoji, but if we have a number line and we have an origin of 0, anything this direction is positive, anything in this direction is negative. Okay, so any number that is less than 0 is negative. For instance, -1, -2, -3, we have put -4. Anything that is greater than is positive. Okay, these little marks right here that I've made, supposed to go all the way through the line, sorry about that, are called tick marks. Okay, tick marks. So if you hear the word tick marks, that's what we're talking about. All right, also we're going to identify a term said to be integer. What is an integer? Okay, an integer is any number on a number line, both positive and negative, that associates with one of these tick marks. So any number, -1, -2, -3, -4, on to infinity into negatives, and then +1, +2, +3, +4, and anything into infinity of the positives. That is what an integer is. So often you will see a line that looks like this with 3 dots and -1, 0, +1, and then 3 dots and this kind of look. That would be a set of integers. All right, you'll get into more of that later on, but we just want to show you that basically it's negative numbers and positive numbers. Okay, so on the top of page 27, actually the middle of page 27, we see these comparison signs. And again, I kind of made fun of an emoji of having these two symbols, but let's talk about what these symbols actually represent. Okay, we know this is an equal sign. We know this is greater than. So think about this, all right? If I have a fish, right, and this little fishy is swimming into the mouth of this, it's greater than, okay? There's the teeth of the shark, right? And if I have the little fish and it's swimming this direction and it hits the point, it's not going to be eaten, and it's less than, okay? I'm sure you've seen this. And then if it's equal to, obviously we're going to put an equal sign. So let me give an example. If we have a -2 and we have a +2, from left to right, we always read the equations from left to right. -2 is greater than, equal to, or less than. Which one of these than +3? Okay, well, -2 is less than +3, right? Because if we look at a number line and we have the 0 as our origin, we have -2 here, 1, 2, 3, we have +3 here, we know that 2, right, is less than 3. we can see that on our number line. So we would use this as a symbol. All right, to do the other way, to show equals, we would say 2 and 2. 2 is equal to 2. That's easy to see. Or we could say that 5 is greater than 3. Okay, and again, on a number line, if we had 0 as origin, we had 5 over here for 3, we can see that 5 is greater than 3 because 3 is this side of it on a number line. Okay, so I think you might understand this pretty easily. So let's look at example 1. It says arrange the numbers 0, 1, and -2 from least to greatest. All right, so let's just make sure we know where those numbers fall on a number line. There's 0, there's 1, and there's -2. Okay, on a number line. So least to greatest, we would say -2, 0, and 1. That's our answer. All right. You can use number lines to help you arrange these, or if you can do them in your head, great. Look at example 2. We have -5, and then we have 3. All right. So what is this asking? It's asking for less than or greater than or equal to. All right, so -5 is, I would say, less than 3. Okay, does that make sense? Yes, because on a number line, if this is 0, we have -1, 2, 3, 4, 5. We got -5 here. We have 1, 2, 3, +3 here. We know that -5 is less than 3 because of this number line. It's way this side and it's in the negatives. Okay, so pretty easy to find out what symbol we use. So our answer literally is that symbol. That's all we're looking for. All right, turn the page and let's go to number 3. Number 3, or example 3, says show the addition problem on a number line, and it just says 3 plus 2. Well, we know that equals 5, but how do we do it on a number line? Okay, this is how we do it. We know that we have 0, 1, 2, 3, 4, 5. All right, so we're going to start with our first number here, and we're going to go from, and I'm going to do this in a different color so you can see this, right? We're going to go from, we're going to draw this dotted line up here, 0 to 1, 2, 3, right? Because there's 3. And then we're going to continue to extend that, and we're going to say we need to be plus 2. So let's go up, and we're going to go 1, 2. Well, where does that end us on a number line? 1, 2, 3, 4, 5. So our answer on a number line looks like this. We don't want a simple answer. We're looking for it on a number line, so you're going to do something like this, okay? And you can see that we have 3 and 2 equals 5. Okay, so the same is true on example 4, where it says 5 minus 3. Well, again, it says to show on a number line, so let's do this. Let's put our origin in there. We know we have to go at least to 5 tick marks, 2, 3, 4, 5. So there's 5, and we're going to start with 5, right? So let's draw our little dotted line up, and we're going to say 5 minus 3, right? So if we went from 0 and we went to 5, that's our first one, and we're going to subtract 3, 1, 2, 3, where does that end us? We have 0, 1, 2. There's our number. Equals 2. That's what we're looking for. Okay? Pretty simple. Example 6 then is just an easy example of subtraction problem. Okay, so it says simplify 376 minus 840. Well, a couple of things. You know that usually when you subtract, you put the bigger number like this, 840, on top of 376. And that's how you're going to get the correct answer. But the problem is because this number is less than 840, if we were to do a number line and go from 0 all the way to 376, and we were to subtract 840, that means we're going to continue to go into the negatives, right, of that. So if we started at 376, right, and we went up and we subtracted another 840, our line would go this way for a long time. That means our answer is going to be negative. If it was like this, 840 minus 376, we would start with a positive 840 and we would end up with a positive answer, but that's not what the question is asking. And I'll let you do this math. I think you can do this without a problem and come up with this answer. But here's what I want you to be careful of, okay, is this sign. It's going to be negative because of what we've learned with our number lines, okay? All right, let's talk about sequence. Okay, the next section here talks about sequence, and at the bottom of page 29, it gives a list, and it says a sequence is an ordered list of terms that follows a pattern or rule. All right, so if I said this, 2, 4, 6, 8, on and on and on it goes, we would know that we are simply adding 2 to every single value, right? So that's how we get the next number. Okay, so 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, and on it goes. Okay, same can be true of odd numbers, right? 1, 3, 5, 7, and again, we're just adding 2 to every single one, and we're getting those family groups, and it's going to be even, and it can continue on. Okay, so that's an example of what we call an even or an odd arithmetic sequence. All right, we're going to give some that are a little bit challenging, not just 2, 4, 6, 8 or 1, 3, 5, 7. If you look at example 7 on page 30, we have 1, 4, 9, 16. What in the world is happening? It says the first 4 terms of a sequence are shown below. Find the next 3. So we want to find this one, and this one, which means we have to figure out what's happening in between each of these so that we can come up with these so that they're right. Okay, look at the solution on page 30. It says this sequence is neither arithmetic nor geometric. In other words, it's not the 2, 4, 6, 8 kind of problem. Okay, 1 to 4, it seems like we would add maybe 3. 3 plus 1 is 4. And if we added 3 plus 4, we would get 7, not 9. So something else is happening. All right, so it says here we'll describe 2 solutions. First, we see that the terms increase by the size, increase in size by a larger amount as we move to the right in the sequence. In other words, between these two, we had a plus 3. Between these two, we had a plus from 4 to 9, we had a plus 5. From 9 to 6, we had a plus 7. All right, 3, 5, 7. Do you see a pattern there? Okay, so if we had 3, 5, 7, those are odd numbers. 3, 5, 7, what's the next one? It'd be plus 9, then plus 11, then plus 13. 3, 5, 7, 9, 11, 13. So if we did those, could we find the actual answer? And I think we can pretty easily. And we're going to come up with 16 plus 9 is 25. And then we're going to say 11 plus 25 is 36. And then we're going to say 13 plus 36 is 46. Or excuse me, 49. 13 plus 36 is 49, excuse me, okay? So, pretty easy to find out, and we note that 25, 36, and 49 will be our answers, the next three in the sequence, okay? Any questions with that? Pretty simple, okay? So last example, rule of a certain sequence is k equals 2a. What in the world does that mean? Well, it just simply means that if we substitute any number I'm sorry, it says 2n, not 2a, same thing. If we substitute any number for n, we could start with 1, we could do 2, we could do 3, we could do 4, we could do 20 if we wanted to. Doesn't matter. K equals 2 times 1. K equals 2 times 2. In other words, I'm just substituting those numbers in a sequence, okay, and I can keep finding that. So 2 times 1, the first number would be 2. 2 times 2 would be 4. What if k equaled 3? 2 times 3, well, it would be 6. And 2 times 4 would be 8. You see the sequence pretty easily. All right, that's your lesson. There's some practice examples, and you can find those at the bottom of the page. Your lesson will be lesson 4.